Now students, let us get into understanding the Newton's second law of motion. And before understanding the Newton's second law of motion, we will visit a concept of linear momentum. So linear momentum, what is linear momentum? Linear momentum is a physical quantity that is defined as the product of mass and velocity of that body. So here you see linear momentum is denoted with the letter P, and P is equal to product of mass m and velocity v. So P is equal to mv. Now since velocity is a vector quantity, linear momentum is also a vector quantity, and its direction, the direction of momentum, linear momentum, is same as the direction of velocity or direction of motion of the body. The SI unit of linear momentum would be the product, since it is a product of mass and velocity, it will be kilogram meter per second. Now, how does linear momentum help in understanding the Newton's second law of motion? Newton's second law of motion states that the rate of change of momentum of a body is proportional to the applied unbalanced force in the direction of the force. So, if you write it down mathematically, force is directly proportional to rate of change of momentum. Now what is rate of change of momentum? Rate of change of, whenever you talk about rate of change of something, you have to divide it by time. So here we are talking about rate of change of momentum. So the change of momentum for any body would be mv minus mu. mv is the final momentum and mu is the initial momentum, where v and u are the final and initial velocities. So F would be equal to mv minus mu divided by t. And force is equal to, here we state that force is equal to the rate of change, is proportional to the rate of change of momentum of that body. Now in the next slide, we are going to understand how you derive this magnitude of force using the Newton's second law of motion, because we had discussed earlier that Newton's second law of motion is used to derive the magnitude of force. For any body, what is the change in momentum? Change in momentum would be P2 minus P1. P2 is the final momentum and P1 is the initial momentum. What would P2 be? P2 would be equal to mv, where v is the final velocity, and P1 will be equal to m into u, and u is the initial velocity. So the change in momentum would be mv minus mu, and the rate of change of momentum would be mv minus mu divided by t. So F is directly proportional to m bracket v minus u divided by t. Now what is v minus u by t? V minus u by t is actually acceleration. So we can write F is directly proportional to ma. Now to remove the proportionality sign, we replace it with a rate constant, with a constant term that is called the constant of proportionality, and it's denoted by the letter k. So F is equal to kma. Now how do we get rid of this k? Because k is a constant, it would remain a constant irrespective of the value of force, mass or acceleration. So for any value of force, mass or acceleration, k will remain constant. So the unit of force is defined in such a way that k becomes equal to 1. So we can remove it totally, because whether you write 1 or not, it doesn't make a difference. So one unit of force is defined as that force which produces an acceleration of 1 meter per second square in a body of mass 1 kg. So 1 Newton is the SI unit of force, and 1 Newton of force is actually defined as that force which produces an acceleration of 1 meter per second square in a body of mass 1 kg. So in that case, F would be equal to 1, m equal to 1, a equal to 1, so k will automatically become equal to 1, and since k remains constant throughout, so we can get rid of it. So we essentially write F is equal to ma. Here the constant proportionality is 1, so we remove it. So this is how you actually calculate the magnitude of force. Force is equal to mass into acceleration. So the second law of motion is used to calculate the magnitude of force acting on a body.